question here. If you worked it out, you should get an answer. I haven't actually worked it out myself yet, so let's have a look. Okay, so you almost get 6,000, so about 5,800 joules. Okay, just carrying on. So it's in between 5,000 joules and 6,000 joules. Okay, in this case here, a box has a weight of 50 newtons. Calculate the work done on the box to lift it straight up 78 centimeters. Now, what you've got to think about here, this box has a weight. So to move this thing up the top there, at a constant velocity, we need to oppose the weight with a force that is equal to the weight. Okay, and that's a continuous force. Now, you might think about, well, we need to accelerate and decelerate it at the start and finish. Well, on average, okay, the weight will equal 50 newtons. So the force will equal 50 newtons, which will be the same as the weight. So let's just put this in. W equals Fs. So it's going to be 50 multiplied by 0.78. Okay, and we get something there. 39 joules of work done. So this box has actually gained 39 joules from the work done on it, from moving it to the bottom to the top. So if we actually look at that like that one just before, we pushed at a constant force of 50 newtons, okay, over a certain distance, okay, in 0.78 meters. Then if you look at the area under here, we multiply this side here, this force, multiplied by this side here, some sort of displacement. So force times displacement is going to be equal to the work done. So area under a force displacement graph is equal to the work done. Now, if we're looking at this one here, let's consider a body mass m accelerating from rest on a frictionless surface until it attains a velocity v. It travels a displacement s while accelerating. So what we're going to derive here is essentially the kinetic energy formula. So if we got this formula here, say the formula for work done accelerating the body and the force required. Okay, so force multiplied by displacement is the work done to get it to this sort of speed. F equals ma is your force required. Now what we're going to do is replace the force in the work equation with the ma. So let's do this. Let's do this over here. So W equals MAS. So this is number 3. The displacement S can be found from S equals half AT squared. Substitute the formula for displacement into the equation 3 for S. So W is equal to M times half AT squared times A. Okay, let's bring this over here just to make things difficult. So W, your work done, or your energy gained, is going to be equal to M times half times A squared times T squared. Okay, now A times T is the same as V, okay, velocity. Remember, from A equals V over T, so that means if we replace the A and the T with a V, so we're going to get M times a half times a V squared, okay, because it's A squared and T squared. So, put into a more usual format that you've seen before, we get kinetic energy is equal to half mv squared. So car mass of mass 1200 kg traveling on a straight road of 14 meters per second. What kinetic energy does it possess? So EK equals half mv squared. So it's going to be half times 1200 times 14 squared. Okay, so that equals, I'm just going to use 2 sig fig because we've got 2 sig fig actually in the question, so it's about 120,000 joules, okay, or 120 kilojoules. Now, if the car actually doubles its speed, what's its new kinetic energy? It is not equal to 240 kilojoules. It is not double the original kinetic energy. So let's have a look. So it's going to be half times 1200 times 28 squared. $470 kilojoules. Okay, so here we're going to look at the formula for gravitational potential energy. So what are we actually doing here? We're deriving formulas. Okay. So consider a mass m being moved through a vertical distance h. Work done equals the gain in gravitational energy, which is force times displacement, with the work done for moving that mass. We've already done this already. Okay. What is the force? Well, it's equal to the weight. Remember, the force that we have to do going vertical is the same as the weight. So what is our vertical force equal to? Well, how do we calculate it? mg. Okay. So we might just substitute h for the s there. Okay, and then we get gravitational potential energy is equal to mgh. Lift a box that has a mass of 5.1 kgs from the floor to a shelf 78 centimeters off the ground. How big was the change in gravitational potential energy of the box? So EP equals mgh. So that is 5.1 times 9.81 times 0.78. So that's about 39 joules. Okay, so the next thing we're looking at is essentially is conservation of energy. This will be the next video. Conservation of energy is very important. We've already mentioned it a few times, but because we talked about, at the start of the universe, everything came from one big bang, and that was all the energy that was provided. So conservation of energy is a very important law that you need to find.